AP. Section 1-2 is on finding limits graphically and numerically. The learning targets. First one, I can estimate a limit using a numerical or graphical approach. Second, I can list the ways that cause a limit to fail to exist and also recognize each of them, whether it be in a graph or in an equation. One of the three big ideas in calculus is a limit. A limit of a function, if there is one, if it actually exists, for some x value, and the book will call it a, is the height the function gets closer and closer to as x gets closer and closer to a from the left and the right. So a limit basically is the height of the function. That's the key part. The height of the function. The limit is what the y is approaching. Limit is what the y is approaching. So in class, we already did example 1, and we basically just graphed y equals 3x minus 1 as the linear function it is, and we went through, we basically used the slope-intercept form, just the short version here. So -1 is the y-intercept, and we counted up 3 and right 1. And we got a nice picture of my rising line. And then what I basically did is I introduced you to the notation, like how we're going to write these this year. And so I told you for limit, you're going to see the notation LIM. And underneath the abbreviation for limit, it's going to give you a statement. It's going to say x approaches, and it will use like an arrow for this. And it will give you a value. So, 2 maybe. I think that's the one we did in class. So, the limit as x approaches to of, and then the expression they'll give you is basically the expression behind the equal sign in your equation. So, for number 1, I modeled in class, this is the graphic approach, and then I'm just showing you how that the textbook is going to most likely write your problem. So it's going to look something like this. So limit as x approaches 2 of 3x minus 1. Again, this is how you'll write it. And so we'll take a look at the graph, and we'll notice that the way this is worded, the limit, if it exists for some x value a, is the height of the function, the height the function gets closer and closer to as x gets closer and closer to the value. Well, a in my problem is 2. And so what I'm going to do is I'm going to come in from the left side. Here is 2, obviously on the x-axis, right here. And what you're going to do is your eyes is going to get closer as you travel across the x-axis. You're getting closer and closer to 2. Notice the y values. Like you can pick any value you want, but like let's say I'm at -2. Well, here's my y value. Looks like -7. When I get to -1, the value is at -4. When I get to 0, the y value is -1. But again, the question is, as x approaches 2, what are the y's doing? We can tell in the graph, and I made the same comment in class, you can tell the y values are increasing because this is obviously a rising graph. Now when you get to 2, the location on the graph is 2, 1, 2, 3, 4, 5, 2, 5. And so the ordered pair is 2, 5. It doesn't matter whether I'm coming in from the left side of 2 or the right side of 2. You're basically looking at the graph and trying to decide what the y-coordinate is, because the y will be the height. And so you would just simply answer this saying the limit of 3x minus 1 as x approaches 2 will be 5. On the second one, g of x is equal to x cubed minus 1 divided by x minus 1. Okay, you notice that this problem is a rational problem, and we know that because obviously it is a quotient. And a few things from pre-cal that we learned in the past is how to, we learned how to graph rational functions by looking at VAs, vertical asymptotes, and we'll start there first. So the first criteria is to figure out this graph where the vertical asymptote or asymptotes are. And basically the way you do that is you take the denominator and you set it equal to 1, set it equal to 0, and you solve. And so when you do that, that means x is going to be equal to a positive 1. So then we're going to go over here to the graph, and we're going to go to 1. And at 1, we are going to draw in our asymptote. Okay, then you're going to try to figure out if there is a hole. Now the hole is going to occur, if there is one, it's going to be the place or places where this equation, if there's any x value that cancels. And so in this case, when I look at it in terms of like straightforward, I don't see anything canceling from left to right. So we'll kind of leave that out for now. And then we're going to move on to the HA. And that is going to be found by looking at the power on x on top and the 1 on the bottom, and then kind of making the call as to what we think it's going to be. So, like based in pre-cal, when the power on top is bigger than the power on the bottom, then that means it's going to stretch and there's not going to be a horizontal asymptote. When these are the same powers, then the horizontal asymptote is the equation y equals, and it's the ratio of the coefficients. And then last, when the coefficient on the bottom is bigger than the top, so the top is smaller than bottom, then the horizontal asymptote will be on top of the x-axis, which is y equals 0. And that's just a quick review on how to find the HA. Okay, and so this is pretty much where we stopped in class last time. So based on what we see right now, I'm going to have to go to your graphing calculator. And because this is as far as we got, and we didn't kind of finish the thinking process, go to y equals and type in the x to the third minus 1 as the numerator of this rational function, and divide that by x minus 1. When you hit graph, you're going to actually see a parabola show up. Very similar to it is a parabola, basically. Okay, so that leads me to believe this. So when we're working these problems, you can always fall back on the graphing calculator, obviously if it's a graphing calculator question. And when I typed it in just now, I'm seeing a parabola on my screen, which means that even though it does appear to be rational, and we started with the same criteria we did in pre-cal, it really didn't turn out the way that we initially thought. And so what we're going to do, I'm going to actually backspace here. And we are going to handle this a different way. So this is a good example on, I tried it one way, I did my criteria, I went to my graphing calculator, and I know there's not an asymptote there, just based on my picture. So that must mean I didn't do my algebra work first. So we're going to fix that right now. So I know we did it the other way in class, so let's go back and just kind of X that out and start new. One thing that we need to notice, that is actually a DOC problem. That's why it's different. It is a difference of cubes. And if it's a difference of cubes, we actually learned in Algebra 2 how to factor those. We just have to remember now. I can't factor the bottom, so I'm going to kind of leave that alone, x minus 1. When I'm going to x cubed minus 1 to factor it, I take the cube root of the first term, which is just x, bring down the same sign. I take the cube root of the last term, cube root of 1 is still 1. And then we factor DOC problems into a binomial times trinomial. And to get this part, the rule is for factoring difference of cubes. You're going to square the first, change the sign, multiply together, x times 1 is just x, always a plus sign, and square the last. And this is your last term, so 1 times 1 is 1. Okay, go through that again. X to the third minus 1 is a difference of cubes. It does factor, so anytime you're given a rational equation, this is the whole point. When you're given a rational equation, please check to see if you can do some algebra work first, maybe factor it to get it down to more simplified terms before you start listing the criteria, the vertical asymptote, and so forth. You're going to do the DOC this way, the cube root of x to the third, drop your same sign, the cube root of 1. Then again, the trinomial is going to be square the first, change the sign, multiply together, always a plus sign here, and then square the last. This is helpful because now we see factor times factor on top divided by a binomial on the bottom. What we notice is that this factor is the same as this one, and so we are allowed to cancel those. And so this problem now becomes g of x is equal to x to the second plus x plus 1. And so that makes more sense as to why the graph on the graphing calculator a minute ago was a parabola. Okay, and so you can kind of just go to your graph. You can go to the table feature if you want on the calculator and go from there. But I just now canceled a factor, so let me write this down. I did actually cancel a factor with an x in it, so this one actually does have a hole, and the hole is going to exist where the canceled factor, which is x minus 1, is set equal to 0. And so that is going to mean this, that this graph on the graphing calculator, it does appear to be a parabola. Let me plot a few points here from my table on my calculator. I see negative 3.7 on my screen, so you're allowed to do it this way. I see negative 2.3, negative 1.1, 0.1. Okay, and right there tells me this is a parabola on the screen, and I have 2 points that are kind of side by side. I know that the vertex is somewhere in between. Let me go back to the graph. It's a little bit above. Let me fix that. So we'll just give you kind of an estimate there. And then again, when you go back to the table, you notice that on your table right now, if you're looking at that, that says 1 error, 1 comma error, and so the y value is going to be missing on that location, and so that's why there's a hole there. And so I'm just going to kind of sketch this in. Here's my graph. Okay, not a great one, but that's my rough sketch. And at 1, there's a big hole there. That's a pretty good graph for that problem. And so this is the graphic approach. Okay, and now what we can do numerically, we talked about this in class, numerically, you're going to pick values close to the a. Alright, so let me come up with the x value here, just to kind of give you a sample. So let's say now the problem says find the limit of x to the third minus 1, same problem, divided by x minus 1 as x approaches, and then you can pick any value you want. I'm just going to use 0. Okay, so what I want you to do numerically now, if this is your question, you're going to go to your table. That's your x's, and this is your g of x's. This is your y's. Put this value, whatever they give you, kind of in the middle of your table. And then you're going to pick numbers that are bigger than 0 to the right and smaller to the left. So I'm just going to do this. Actually, let me get even closer. I'm going to do point 0, 0, 0, 1. And that's what I was talking about in class. Get as close as you can. Okay. And then less than 0 are negative numbers, so and you're at liberty to choose whatever you want, unless sometimes the book will choose the values for you. But if it's free range, you can choose whatever you want. But I will caution against this. I wouldn't choose like 1, 2, 3, and -1, -2, because then it's going to be harder to make the call what the limit is. So really do try to get real close to 0. Think about it in terms of a number line, and like what's really close to here and what's really close on the left side. Alright, and then so the graphic approach we've done. Now we're on to, again, just reminding you the numerical approach. And so if this is your problem, making sure you're following me, that is your problem. Find the limit of this expression as x approaches 0. You would take your a value, which is here. You would put it in the middle of the table. You would choose numbers to the left of 0, numbers to the right. You would then, as quickly as you could, type in, kind of substitute this value in for x in the top and bottom, and use your calculator. Okay, so you're going to do that, and then you're going to fill these in. We'll try that for the next couple minutes. Okay, so once you've typed in these values for x into this g of x function, and these are the values I got. For the first one, 0.9100. Remember my comment in class, from here on out, always make sure you give me 4 numbers after the decimal. The next one I got 0.9901. Skipped over 0 because that was my A. And then I got 1.0001, 1.0010, and 1.0101. And you can see that as x got closer and closer to 0, my x values got closer to 0 on either side. My y values are very close, and they're very close to what? And that is going to be the answer to the limit. And so you can tell that these values on the bottom for g of x is approaching 1. And so the answer to this question, to find the limit of x to the third minus 1 divided by x minus 1 as x approaches 0, you would give the answer of 1. And you also can check it graphically. So again, what I just did down here is called the numeric approach. This was the graphic approach. I could ask this question and have you show both methods. But just to verify on the graph, when you go to your graphing calculator, when x approaches 0, then the y value is 1. And you can see that on my picture. Alright, moving forward, often functions are undefined at a point, but then they still approach a limit at that point. So what that means basically is often, like in the last picture, you're going to have graphs that may have a hole in them, but then when they ask you to limit as x approaches that x value, there still can be an answer to that. The existence or non-existence of a function at x equals c does not determine the existence of the limit of the function at x approaches c. The existence or non-existence of a function at a certain x value does not determine or mean that, there's going to be an existence of a limit as x approaches c. So I'm going to use this example to kind of model that idea. And again, that was in the reading from the textbook. You can see in my example, I've given us piecewise function. Piecewise from the past, pieces of pictures. And so we're going to start with f of x equals 1. And we'll do that in red. That is y equals 1. That means go to the y-axis, find 1, and basically draw a line through it. And so I'm just going to put points here. Just randomly. We all know what that looks like. And then I'm going to look back at my domain statement, and it says only graph this when x is not 2. Okay, so I need to put all these points up here on my graph paper except for when x is 2. So right here, get rid of that one. And so you're going to connect those in a horizontal line. Okay, and so what I'm going to do right now to show that is I'm going to do this. Okay, second, f of x is equal to 0. So that's my second piece that I have to graph. And it is saying to go to the y-axis, find 0, put a point there, draw a line through it, and that's going to be modeled by the graph on top of the x-axis, the one in blue. But I'm only supposed to show that blue line when x is 2. Well, when x is 2, that means all these other points need to go. So I'll basically erase what I did, except for that one value. Make it more clear. Okay, so what we're seeing right now is a horizontal line with a hole in it at x is 2, but then right underneath it, we're seeing a point at x equals 2, like at 2, 0 on the graph. The question says, find the limit of f of x of that function as x approaches 2. So we can tell that the horizontal line is, or has a hole in it, so it's not continuous. What is the limit? What are the y's doing as x approaches 2? And so we're looking from the left, coming in, and we can see that, like, I'm going to be random here. If I choose -9, well, the y value is going to be 1. If I choose 1, 2, 3, 4, -4, the y value, the height of the curve is still 1. At 0, it's 1. At 1, it's 1. At 2, there's a hole there. At 2.1, it still exists, though. At 2.2, it exists, and everything to the right. So, excuse me, it says the existence of a function at x is c. It doesn't determine the existence of a limit of a function at x approaches c. So the answer to this question, even though it's undefined, the values of the y's is approaching 1. Okay, next. Limits that fail to exist. There are 3 types of problems that do not have limits. Number 1, and while I'm thinking about it, this I have seen released as a question on the AP exam. This is an important concept. F of x approaches a different number from the right side as compared to the left. So if I notice in a graph or in a table that the right side of my y values and my left side of my y table are like approaching a different number, then that means that the problem does not have a limit. Number 2, if f of x is increasing or decreasing without bound. So like if it's going stretching, getting closer to an asymptote. So as x approaches c, it's going up and down, and it's not really going to stop. Then there's not going to be a limit, a height of the curve. And then the third way that a limit can fail to exist is if it oscillates between two fixed values as x approaches c. That basically means that if it like jumps back and forth between two numbers, like it's going up and down, then you can't really make the call as to what the limit of that entire problem is. And so here's some, just based on those facts and the way I described that, here's some problems that match these to make sure that you understand. So we're going to start with number 1, and again, you should have your graphing calculator handy here. And we're going to be looking at the limit of this function as x approaches 0, and it's the absolute value of x divided by x. And you've heard me say this several times in this section, but I want to make sure that you understand there's different ways to get to the answer. One option is the graphic approach. You can go to your calculator, you can type in the function, you can look at the graph, and then kind of make the call as to what you think is happening as x gets closer to 0. What's happening to the y's as x gets closer to 0. Second approach is the numerical approach. You can actually do that in a table form. You can pick numbers close to 0, to the left, to the right, use your calculator, give me values, and then just study the y's in the table and see what's happening. To make this a little bit faster, what I'm going to do in this, in the notes, is the graphic approach. So I'm going to ask you to grab your calculator again. You're going to type in the absolute value of x and divide that by x. And then you're going to graph. Okay, and when you did that just now, you should have gotten it correctly, you should have gotten that picture on your screen. Okay, so as x approaches 0, what's happening to this graph? Well, notice if I come in from the left at -10 and -9, the y value is at -1. Like all these y values are -1. As if I approach it from the right side and I look backwards, like this direction towards 0 on the x-axis, the y values are not at -1, but they're actually at +1. So that's confusing. When I'm looking at it from the left to the right, it's one answer. When I'm looking at it from right to left, it's another answer. And so because it's confusing, that just means that this one does not have an answer. And that's based on this. If f of x approaches a different number from the right side as compared to the left, then there is not an answer. It fails to exist. And so what we say in calculus, we write, well, it does not exist. I'll write that first. But we write for short DNE, does not exist. Okay, let's try number 2. On question 2, we're going to do the graphic approach again. I want you to type in y equals, and then just 1 over x squared. 1 over x squared. Okay, so we'll try that right now. And what you see on your screen, hopefully, is this type of graph. Something to that effect, okay? Alright, so based on the way it looks in the calculator, and you can also verify that by a table, You can see when you go to the table right now on your graphing calculator, on the table it says 0 for x and error for y, and so that's basically telling me that there's a big asymptote right down the middle, okay? And so this graph's approaching it from left to right, and so if I'm asked, well, what's the y's doing as x approaches 0, again, taking time to make sure you see this because it's very important. When you come in from the left, the y values are getting a little bit higher each time. Now, I know it's hard to tell, but they're getting larger. And they're going to continue to get larger because it's moving this direction. As I approach it from the right side, the x's are moving towards 0. Well, the y's are changing every single second, but there's no stopping it. And it's going to continue without bound. Okay, that's what that means. And so you're going to write D and E for this one. And you're going to do the same thing for number 3. Okay, so you're going to go to your graphing calculator. We're going to make sure your calculator's in radian mode, of course, because we're graphing a trig function. And we're going to type in sine of the quantity 1 divided by x. And you may want to, I didn't do this at first. Mine's in standard window, like -10 to 10 on the window. You may want to, you can even like zoom in on the graph or make the x-min smaller, like -5 to 5, and just see how, like what impact that has on the picture. I think it's easier to see if you'll change the window and make it, like I said, -5 to 5. But once you type it in correctly, and you want to make sure you are doing this at home so you can see what I'm seeing. It's like doing weird things. It's doing this, and it's jumping, and then I see it going down here, and then back up, and then coming back towards the x-axis. And so it is jumping back and forth between numbers. It's going from like a -1 up to +1, higher than +1. And so because it's oscillating, when I move in from the left towards 0 and from the right, it's doing different things. I think I got my graph wrong. There we go. Looks more like that. And so that's trying to kind of model to you what I meant by number 3. So again, there are 3 ways limits fail to exist, and we write D, N, E for the answer, and that is in a scenario when it's approaching a different number from the left side and the right side. When there's like 2 different answers and you don't know which one to give, you say D and E. When it is approaching an asymptote and there's like no stopping the graph, then it's not going to reach a height, and again, height is the key word for limit, so you can't give an answer for that. And then when the graph is like jumping up and down between numbers, you can't give a defined answer for that one either. And so hopefully that has helped kind of clarify some issues we had in class on last time, and we just didn't have enough time to finish. But I want you to make sure that you've taken really good notes. You've read the section. Remember, I told you to do that. Read the section of textbook. And then I will send the remind to you about the assignment as well.